All right, so now what we can do is we can implement a rudimentary store for our users. And this is going to be a little weird, but bear with me. So let's nuke this code out first. And what we're going to do is I'm going to come up here to client, and I'm going to add a new folder called stores. Inside of stores, I'm going to add a new file called users.js, and this will be our user store, not surprisingly. And for our user store, I'm going to say export class users store. Our users store is going to handle everything from getting a list of users to notifying us when a user was added or removed, as well as it's going to tell us if we're logged in and all that fun stuff. All right, well, the constructor is going to take in a server. And we're going to say this server equals server, so we have access to it elsewhere in the class. And then I'm going to delineate something here. I'm going to say users list. Now, how are we going to get the users list? This is going to look bizarre to you guys. I'm going to say const events equals rx. Whoops. We have to import observable from rxjs. Equals observable.merge. And we're only merging one thing so far. We're doing this server on users:list.map OpList. What's OpList? I'll tell you in a second. Let me finish just this one thing, and I'll show you OpList, and then we'll take a step back and talk about this because it's going to be a little crazy. Then I'm going to say this state money equals events dot scan, and I think I'm going to break this out. I can write this more concisely using ES 2015 syntax, but I think I'm actually going to break this out into its own function just to make it a little bit more clear. I'm not even going to use arrow syntax here. I'm going to say function, and the function is going to take in the last item as well as the current operation. We'll fill that out in a second, and we're going to start with state goes into users empty array. We can even make that a little bit more clear as well by saying const default state equals an object with the user's property with an array, and we're going to say state equals default state. So that's what we're doing here. So what's the scan going to do? Well, the scan is going to say return operation on last.state. Then we're going to publish replay of 1, and then I'm going to say this state connect. Okay, so what would OpList be? I think it might be easier to explain this if I write OpList. So let's go ahead and do that. OpList is going to take in a list of users, and it's going to return a function that takes a state, and it's going to say state users equals users. It's going to say state users.sort based off their username. So I'm going to say lr goes into l.name.locale compare r.name. And then I'm going to say return type goes into list, state goes into state. Okay, yeah, this looks a little crazy. But what's going on here is we are writing kind of a reducer, if you're familiar with Redux. It's a similar concept. We're saying, okay, whenever the server sends me a user's list event, map it with OpList. OpList is going to return a function that mutates our state. Now, the benefit of this is that it'll allow us to not only get a list of all the currently logged in users, but it'll also tell us what was the last operation to happen. For example, let's make this more interesting. Let's open up our server modules users here. And let's say that register client, what I'm going to do is I'm going to say set interval. I'm going to create a handler here. And every 2 seconds, and I'm going to say let index equals 0. And I'm going to say const username equals new user index. Const user equals name is username, color is this, get color for username. Maybe break this out a little bit more. And then I'm going to say client.emit users added user. So I'm just pretending that every 2 seconds a new user is logging in. That's it. That's all I'm doing here. It's not super exciting. But how would we model that with our store? Well, it's simple. We would add another operation. I would say, okay, now we can add users. So now we have to add a new operation. So I'm going to add this here. I'm going to say this server on users added map op add. And then underneath OpList, I'm going to add the function op_add user. And what does op_add do? It returns a function that mutates the state. So this function returns a function. I mean, we're writing JavaScript here, so it's something that if you're not used to already, it's a good idea to get used to. And then what I'm going to do is I'm going to add the user in by saying const insert index equals underscore find index state.users. U goes into u.name.locale compare user.name is greater than 0. Then I'm going to say if insert index equals -1, then insert index equals state user's length. Then we mutate the state by inserting the user where they're supposed to be based off the sorting function. And we'll say state.users.splice insert index 0 user, which inserts the user at that specified index. And then we return type add user state. All right, insert index needs to be a let, and I do need to import Lodash. So let's make ESLint happy. Well, actually, let's make this code compile. All right, with that out of the way. So what's op_add do? Well, op_add, it responds to a user added event or users added event, and it returns a function that mutates the state. But most importantly, what's happening here is we're emitting the type of thing that happened to cause the state change, the data that caused the state change, and then the state itself. So the user interface can respond by adding or removing an item, or sorting an item, or whatever. So this allows the user interface to get more details. Now, this isn't so much necessary in frameworks that have change tracking, such as React or Angular. In React or Angular, you would just dump the state straight into the stream, and you would have the framework figure out how to change the user interface for you. In this, we don't have that. Since we're not using any frameworks, we're trying to figure out how this sort of architecture works in the absence of these frameworks. And this is a way to do it. So basically what happens is if we scroll up, we do an observable merge on these two events. We map them to their respective operation, which returns a function. Then we scan it, which is scanning. If you're familiar with scanning, it's a reduce, but for a observable. We scan it, and we say, okay, return the operation applied by the previous state, and start with the default state. And then we publish replay 1, so every time you subscribe to the state, you'll always get the latest state at least once. And then we connect to it so that these two event handlers get hooked into Socket.io without a subscription. If we didn't have this connect here, or this publish here, these events wouldn't be handled by Socket.io yet because there wouldn't be any subscribers. Now, it's okay if this takes a little bit of time to get your head around. This isn't trivial code, and I guess that's the whole point of the series. But let's go ahead and see how this behaves. Let's not worry about hooking this into the component yet. Let's just see how this console logs out, and maybe that will help you guys start to understand where I'm coming from with this. So inside of our services.js, this is where we're going to instantiate our stores. I'm going to say up here, I'm going to say import user store, which I believe I did call it user store, yes. Import user store from stores users. And then I'm going to instantiate it. I can delete all these. I can say export const users, or users store equals new user store passing in our server. It's its only dependency. And with that out of the way, so make sure you instantiate it in your services.js so that your components have access to it. Let's go into application.js and let's listen to it. So I'm going to say services.userstore.state money.subscribe state goes into console log state. And with that out of the way, let's go ahead and jump back into Chrome and refresh. Hop on over to the console. Now, what's interesting is we're not getting any lists because we never requested a list. We're going to fix that in a moment, but we do see our ads. And we'll notice that as our ads come in, we have an array of 5, an array of 6, and we see that our state is indeed changing. And that is pretty awesome. So we're receiving that state change ad every single time a new user is added, or every single time the server informs us that a new user has been added. So before we talk a little bit more about what's going on in our store, I do want to talk a little bit about how we can always get a users list. And so at the bottom of pretty much every store, I'm going to have a bootstrap section. And what that's going to do is it's going to say this server.on, and we're just going to do a normal on connect, and then I'm going to say this server emit users list. So every time we connect to the server, we emit a new users list. And what's cool about that is that'll not only handle the case where we connect for the first time, but it'll also handle the case where if we disconnect and then we reconnect, we will still receive a users list. And again, that emit comes out, the server responds to it with the users list, that gets mapped into the OpList, which returns a function which sets our state to the users and then gets published through this state. So coming back here, we can refresh, and we'll notice the first thing we get is a list of 3 users. Then we get an ad, and now we have 4 users. Then we get another ad, and now we have 5 users. And just a heads up, don't freak out if you let this run for a little bit, and then you click on one of these objects and then open up their state, and you're like, wait a sec, that was console logged out before there were 10 users in there. Why is that happening? Well, it's happening because it's the same object reference, and because it's the same object reference, Chrome isn't enumerating the items in this object until we expand it. But the point is, though, is you can kind of hopefully see what's going on here. If we subscribe to the state, we'll get the action that caused the state change to happen, as well as a fully populated new state, allowing us to query on that state and do other interesting things. So again, it might take a little bit of time to get a handle on this code. By the way, I said I could write this more succinctly, and I can. If I take advantage of a couple ES 2015 features, I can collapse this to scan, and then in parentheses, because I'm going to do pattern matching, state, comma op goes into op state. And that'll accomplish the exact same thing, but more succinctly. So again, it's a little weird what we're doing here, but what's awesome again about it is we subscribe to this one state observable, and we get access, A, to all of the current users that are in the list, and then we get notified of specific changes if something was added or removed or whatever, allowing us to do targeted DOM manipulation. Again, this isn't something you would do in React or Angular because they do all the change detection for you. But that whether or not that's a good or bad thing is up to you and what the application is that you're building. With that, I think that wraps up our users list so far. In the next video, we'll finish our users component. Our users component we're going to implement very, very simply. And we'll see you guys in that video.